Lots of different ones. I think what distinguishes LoRa in particular is probably their use of some proprietary protocol that involves, I think, adaptively changing the modulation scheme or whatever. Fortunately, you can treat it as a black box. You don't really have to know anything about what's going on, because with the software, which is freely available, open source software, and the hardware, which is cheap and readily available through AdaFruit, you can get it going, a bidirectional data link. And over, as you'll see, you can probably do about 1,000 feet point to point with, it's unobstructed line of sight. So, how am I using it? Well, my goal was to get telemetry from a bat house. This is a bat house on Valencia's West Campus. It's a big box. The box is about 5 feet tall and 4 feet wide. And I'm not sure whether it has any bats in it or not. Theoretically, it could hold hundreds of bats. And it's on this metal tower, an awesomely constructed metal tower that is hurricane proof, knock on wood. And, but it's across Lake Pamela, which is a little pothole lake, about 1,000 feet across. And I need to get the data from here to campus so I can do something with it. Originally, I had a Raspberry Pi in a box buried in the ground. I would go out and take the SD card out, and it was kind of a pain. I never did it. The SD card filled up, crashed. So I definitely need to get data in real time, right? Like there is power out there. It has solar cells and batteries, so I could definitely run a link. It's too far for Wi-Fi, at least without a directional antenna. In other words, if I had big gain antennas on each end, I could do it. The problem is I could put a gain antenna out here. But if I talk about putting an antenna on top of building a campus, various authorities get involved, and they want to make sure that everything meets code and so forth and so on. It's just a huge hassle. I thought about a mesh network. I thought, well, maybe I can plant mesh nodes in the woods along the edge of the lake, and we'll just kind of store and forward or something. But that seemed out of control. So I was looking for a point-to-point link.
What about SIM card? You can just push it to the cloud, push the data to the cloud.
I could, and I did have a 2G, I think,
okay,
SIM board. I got tired of having to renew the SIM card and just getting a data-only SIM card. I think T-Mobile at the time was the only one who would sell you just a SIM card with no phone. And so I kind of gave up on that, although it's not highly expensive, and that technology's probably gotten better and cheaper. So I found these boards online, and I watched a video on YouTube. I don't know if anybody watches this guy, Andrew Spice. So he's the guy with the Swiss accent. He's got a whole series of YouTube videos about microcontroller and data comms stuff. He does a very good job. And he did a review of a lot of this sort of new data radio technology. One of them is this one I got from AdaFruit. The actual chip is here, and of course what AdaFruit does is to put the module down on the breakout board, mark it up a little bit, and sell it to you for the convenience of not having to try to solder to some awfully small point, and for some documentation and other stuff. So the module is about an inch and a half by an inch and a half tops. It's very small, and it has its own processor and all kinds of stuff with it. It looks like it speaks, I think it speaks SPI. So you got a pretty high-speed serial interface back to your device. This is the long-range version. I don't know for sure what the difference is, unless it's just higher power.
Is that the integrated antenna there?
No, there's actually a connector, and I've soldered a wire on. It's one of those tiny coaxial connectors, the smallest coaxial connector you've ever seen. It's got some of those on it. So if you did want to use an external antenna, you could. So I decided to do some tests and see what the range was, right? So I set up, this is my server, which is basically just an Arduino with the LoRa board on it. There's the antenna that's about 3 inches long, connected to my Mac, and I'm just basically grabbing data out of an Arduino sketch. So I downloaded, the software is called Radiohead. It's a great name for software, but it's actually a general package of data radio stuff, and it looks pretty good. And so I used that version. And I'm sitting here collecting, and what I'm doing is having the client side, which you'll see in a minute, send its RSSI, Receive Signal Strength Indicator, an indication how good the signal is, back to the server so I can log it. So my idea was I'll take this out to the park, I'll take the client in, you'll see in a minute, walk around with it, and just map the signal strength at various points to see how well it holds up over distance. So this side didn't move, so this is sitting on a picnic bench, and my wife is guarding it. And there's the client side. Now there's a story with this. because I started out, I put it all on the board, because this was gonna be a one-time, lash up, and it's got a lot. Here's the LoRa radio with its little antenna. There's the connections back to an Arduino. Then I added, and a GPS so I know where I am. And then I added a Raspberry Pi to talk to the GPS. So I've got a Raspberry Pi, GPS, an Arduino, and a LoRa board, all on this one thing. And I've got one of those big 5-volt USB batteries strapped to the bottom, right, to run everything. Then I got smart, I thought, and I thought, well, it's hard to hold this thing. I'll put this pistol grip on it, right? That's actually a mistake. I'm walking around the park with this thing, pointing it, and some little kid in a truck, family drives up in a truck, little kid rings out the window and says, "Cool gun." And so then I felt obligated, oh my gosh, so I run over there and tell his dad, it's not really a gun, it's not really a taser, I'm actually making a nap. And so I smoothed everything over, but obviously the gun metaphor was not cool. So I should not have put a pistol grip on it. That's another story. Anyway, this is basically exchanging two-way data. So it sends to the server sends back, and they each keep track of how strong the signal is. Yeah.
I do like your badass shadow though.
Mhm.
Oh yeah. I didn't notice that. That does look cool.
Yeah.
And all right, so anyway, so much. Never be careful of the form factor you make for your IoT devices. It can come back to haunt you. There's a range test. This is a park north of Apopka called the Northwest Recreation Area. It looks beautiful and scenic until you know this is actually recycled sewer water, right? This is basically a settling pond. But it doesn't smell and it looks nice. You just wouldn't want to go in it. And there's a walk that goes a 1 mile walk that goes all the way around it. So it's really easy to sit in the shade of on the picnic table and have someone walk around and just measure the signal strength at every point. And that's what this shows. So the server sitting here, the larger the number, the weaker the signal. Because it's actually supposed to be negative. This would be like negative values. So, but basically the smaller the number, the better the signal. And so when you're right there at the server, the signal is pretty good. It goes down and goes down. This is probably the low point right here, which is basically diagonally across the lake. There's also some trees in here, which I thought would disrupt the signal more than they actually did. Because obviously trees are, this is 915 megahertz radio, so it's about half the frequency of Wi-Fi. But trees are big obstacles. I mean, they definitely interfere with the signal. But this is about, I think it's about 1,000 feet, or 1,000 feet between here and here. So now this is kind of optimal conditions. It'd be better if this were salt water, but I can't really put enough salt in there to get that. But the best range always gotten over salt water. But this is absolutely flat, of course, which makes a big difference. So that's my walk around. And I got these coordinates from GPS and I plotted it on, I used MapQuest because I don't know why I didn't like the Google map or something, but.
Thanks for reminding me that MapQuest is still a thing.
Yeah, actually it's not bad. It's the sections I've used. And I tried OpenStreetMaps and it was a disaster. So I couldn't figure out how to use it. When I did figure out how to use it, it looked like heck. Yeah. So MapQuest still works. So I decided, okay, well, I'll test this out on campus because I'm not going to use it as a recreation area. The bat house is right there. And the building closest, not the closest building, but the closest building that I could get into, because this building is like a special event center, so I can't park anything in there. But I know someone who has an office in this building and in the physics lab. So I thought if I could get from here to this building, I could then hop on the campus LAN. I guess I should ask permission, but I won't. Hop on the campus. I'll make a LoRa to LAN bridge. And I'm looking at the security guy now and thinking, oh man, that sounds right. But we talk about the implications of that. But it's point to point. So
TCS fault if they're not going to block you.
right. I go by, I'll do it, and if they say something, I'll say, oh my gosh, I didn't realize that was a problem, and
I just want to walk back through what you're saying. So you're saying, here's a map of the place where you work.
Yep.
Here's a circle of where the antenna is.
Yep.
And that is the protocol in which we need to talk to the antenna that speaks directly to the on-campus.
Yeah. Now the way the protocol works, you probably got to spend $25 to get one of these radios because the chips speak proprietary. And I could have turned on encryption. It does feature encryption, some AES algorithm. So, but I didn't. But yeah, and this is also a Google Slides presentation, so it's open to the world.
Your bat has temperature is high.
That's right. So
Get some weird
my
reasons.
original plan was to try to go to the free Wi-Fi to Starbucks across Kirkman and go that way, but I thought that might be in trouble. Anyway, this is about 1,300 feet, and that seems to. And the amazing thing is, this is a brick building. Those buildings are all hugely. Schools are built, this reinforced concrete brick stuff, steel, and it's still. We were able to receive it in a windowless office in the back of the physics lab. I believe it might be some kind of strange bounce. I think it might be a bounce. I don't know. I don't know what the data rate. I didn't measure the data rate, so it may be the data rate is degrading as the signal degrades. That may be a part of what the game they play in the protocol, right? It's not working well, they reduce the data rate, probably. But I don't need much of a data rate, because I only want to send a few hundred bytes a minute, because I just want to sample the sensors in the bat house. There's temperature, there's bat ingress and egress, battery charge, and I could send all that in one chunk once a minute and be really happy. So that worked pretty well, and I'm just amazed it worked inside the building. So here's the client, which it doesn't matter what you call a server or client, right? It's really, I call it server and client for sanity, but it's really symmetrical. It's a symmetrical link, and it doesn't matter which one's which. And here with the banana shown for scale, and this is actually inside. That's a exterior brick wall, and we were able to get a pretty good signal in there. And my friend here is willing to plug this into his hub. Well, I'll supply him with a hub, and we'll be on the campus LAN. We won't go on the Wi-Fi because on the campus LAN, just so you know, I'm thinking security. You can plug in. They don't authenticate. You plug in an Ethernet cable, and you will get an IP. You will be good to go. If you try to get on Wi-Fi, you have to authenticate, and you have to go around your tail to do that. So I'll just plug it into the LAN. I actually think the risk is relatively small, and it could turn on encryption. But yeah, anyway. Now, I don't think the same way that our our IT folks do, though, and they may feel that that's a threat. Anyway, that's as far as we've gotten. Haven't actually sent any bat house data, but it looks feasible, it looks workable, and I really like the little radios because I think they work really well. And so I'm now experimenting with some other little radios, like you can get these little tiny, like $3 a piece, 2.4 gigahertz radios that go a few hundred feet. So I play with some of those and see how they work. But the LoRa radios use what's called the ISM band, Industrial Scientific Medical. It's a no man's land that's internationally carved out in every country. And there's chunks of frequency that you can use if you want without a license, but you've got to agree that you can't complain about interference. That's the basic ground rules, right? And there's a bunch of stuff in those bands that makes interference too. Obviously, Wi-Fi and microwave ovens don't necessarily get along very well. But so far, so good. So, any questions? Yeah.
How does the protocol work? It sounds like it's point to point. Is there like a channel or something that you put them both on so they can talk to each other?
I think this is basically broadcast because I don't recall any channelization or addressing. I think I was using the most basic protocols, kind of like UDP. It's kind of like send a packet, get a packet, send a packet back. There's a TCP/IP stack apparently in the Radiohead software that I could load on top of this, and I think that might provide some addressing. Or point. I don't know if it will do point to multi-point. Maybe there's even a way to do point to multi-point. Well, if I had addressing, I could do point to multi-point. But I was just doing the dumbest way. No retries, no retransmission. Just fling a packet out there and see if it got there. But I didn't see a very high packet loss rate. Again, I believe that maybe because the data rate was very low. So we'll see. Other questions? Yeah.
And maybe this is a piggyback on what this guy said, but can we set up a mesh network with this at 1,000 feet?
I think these don't mesh. Okay. I don't. Although that's not to say you couldn't construct a bridge of some kind, right? Comes in this one, goes out this one, with some kind of CPU in between. I believe you could do that. They are frequency agile, so I think you could shift one to the high end of the 900 band and one to the low end, maybe. And with directional antenna point, I think you could construct a bridge. I don't think they inherently do it. It's not like particle stuff like the boron and whatnot that's automatically made to form like a Wi-Fi mesh network. The fact that it's not Wi-Fi and it's about half the frequency of Wi-Fi probably helps with the range too. Because although 900 megahertz is up there, it's basically the wavelength is twice as long as Wi-Fi. And I think that probably helps you with some obstructions. I don't know. Once you cross into the radio domain, you cross into the analog world of weird physics, right? And it becomes very quickly not software, not electronics, but physics. And that's not my forte. But I do know that it's also possible if you construct a gain antenna, some kind of directional antenna, you could probably go a lot more than 1,300 feet. They claim a mile, and I'll bet you with a decent antenna you could do a mile, unobstructed. If there's a lot of stuff in between, who knows? Or if somebody powers up some other device in the 900 megahertz band that's a RF heater or something, well then you'll have trouble and no way to complain. Any other questions? Yeah.
So on the back house, do you have any source of power source to power this?
Yeah, I have solar cells and a battery, which is, I don't know what the power budget out there is, but to run an Arduino with a LoRa radio, we're gonna have plenty of power.
What are they putting on the bat? How excited with that?
All there is in the bat house is there's a Arduino Mega that's reading 3 thermistors and 4 break beam sensors. And so it's just sitting there polling those sensors. And then once a minute, it serializes the data and just sends a string down a long USB cable to something at the bottom. So I would suspect that that's not drawing over continuously. It's probably drawing 1/10 of an amp or something. I would think it would run for a very long time. I ran a Raspberry Pi out there and it never crashed.
For your bat house client side of it, what do you do for your environmental protection, your temperature, humidity?
Oh, the sensors are mounted under, I don't have a good picture of the bat house, unfortunately. The sensors are mounted underneath the house. The temperature sensors are these big old ugly copper thermistors that you get for water heaters. So I drilled those through the side of the bat house and there's a box that covers them. So they're not very sensitive and they're not very good, but I don't think you can destroy them. Because I was concerned that bat urine and feces might have a deleterious effect on those little plastic TO92 packaged sensors. So I use these sort of industrial looking sensors. And so we'll see. I mean, I think there's some bats in there, but I could tell for sure because there will be a pattern of emergence and re-entry in the evening and in the morning. That will be very clear if they're there. Yeah.
How high off the ground is the bat site?
That I can pop back to that thing. It is probably oops. That is probably 15 and 20 feet high.
And where's your antenna?
Oh, when I was doing it, the antenna was, I had it clamped right about here. So I wasn't even at the top. Again, yeah, you could also gain some. I also have a big honking Wi-Fi dish I could theoretically put on the top.
Maybe the wrong side.
Yeah. Well, it might, sometimes it might work. Sometimes if you have multiples, it'll work. So if it were a multiple, submultiple of 2.4, it might work. So, yeah.
So I just have a recommendation. So if you're finding that you're having a hard time getting bats there, I found out this holiday season that bats really love Christmas wreaths.
Oh, really?
Circlings. So,
Wow.
if you need to attract some bats,
There's
find
lots of
wreaths
schemes
in there.
people have for tracking bats, and I don't know if any of them ever actually work. But the best way, of course, is to have some of their current habitat destroyed. This happens every now and then when they tear down like a bridge, an older overpass, because those overpasses were popular bat roosts.
Yeah.
And when they tear one of those down, all of a sudden there's thousands of bats looking for a new home, and that works out well for you. But otherwise, you've got to wait for, we're not sure, an individual bat to find it, the equivalent of like a leader or an Instagram influencer to find it or whatever, and lead the other bats there. No one really understands how that works. So.
How close is the tower to the lake?
Oh, it's about 50 feet this way. So it's actually on a hill too. It's a berm that's leftover construction dirt from years ago, so it's on a little rise. So it's even higher than it appears to be over average terrain.
Is that your truck?
No, that's the truck of the guy who put the tower up. And I know you like those kind of vehicles, but the fact that he has like a spare tire on top probably suggests this. This tower, by the way, and I'll stop, is those are light poles, steel light poles, and the engineer who did this did it for free, but it was like a science project for him. So he had these poured full of concrete. So they're 6 inches square, they're full of concrete, and the whole thing was hot dip galvanized. Somewhere in Orlando is a tank of molten zinc, big enough to dip that thing and bring it back out. This is built out of hardy board, that ceramic, that concrete board. So I think it's going to be there for a while. And there's pillars, so 6-foot long piers that are sunk in the ground here with another 3 feet of concrete on top of them. It's not going to blow over. There may or may not be bats in it. It's not going to blow over.
Awesome.
Okay. All right. Thanks.
Thanks, Jerry.
Sure.
Or should we say Batman?
Yeah.